Hello, everyone, and thanks for joining us today. I'm Harry Urban, publisher of Woodworking Network and FDMC Magazine, and we welcome you to our webinar, How to Automate 3D Models for Router and Saw Optimization, sponsored by CIM-TECH. We have two presenters today. First, we have Kenny Belfato, the National Sales Manager for CIM-TECH. Say hello, Kenny.
Hello, everybody. Thanks for attending.
Kenny's been involved in CAD/CAM training, execution, development, and support for more than 30 years. He's worked with dozens of manufacturing companies from around the country from a variety of industries. Kenny's a wealth of knowledge, so I encourage you to ask questions from here on out. Also working with Kenny this afternoon is Giovanni Ramos. Say hi, Giovanni.
Hey, everybody. Happy Wednesday.
Giovanni's been with CIM-TECH now for 3 years, and his background is in technical sales. And I'm going to turn it over to Kenny and Giovanni in a moment, but just a little housekeeping. This webinar will be recorded so you can view it again or share it with a colleague. There are also a couple of handouts attached on your viewer console that you can download at any time. One is a CIM-TECH brochure, and the other one is this actual PowerPoint presentation. We're going to make this a very interactive session. We have some polling questions that we'll push out to you as we go through the presentation, and we'll share the results with you in real time. Also, after the webinar ends, we're going to push out a survey to you and would greatly appreciate it if you could take a few minutes to fill it out. And then finally, we encourage you to ask questions, and we'll do our best at the end of the presentation to answer them or get back to you as soon as possible after the webinar ends. With that, I'm going to turn it over to Kenny.
Thank you, Harry. Today, we're going to talk about how we automate 3D models and assemblies, and not just automate, but optimize their yield across a router and a saw. A little bit about CIM-TECH. We established in 1986, and back then, Autodesk was really just starting out, and we realized that your ability to program a CNC machine is only as good, the machine's only as good as your ability to program it. And we decided to partner with Autodesk and build a product that's integrated inside of CAD so that you get CAD and CAM combined together, and that's what we call CIM, or computer integrated manufacturing. And that whole idea of integration leads us to a single file that has both the design and the manufacturing intent all stored inside of one file. And we've had that philosophy throughout the years. And that's our first name is CIM in CIM-TECH. So today, Giovanni will discuss it.
All right. So today what we have on the table for everyone, we're going to be discussing integrating router, saw, and point-to-point machines. We're also going to be covering boosting yields across the different types of machines. We'll be specifically going over SawSim optimization for router and saw. And then, of course, after the presentation, we'll be taking a few questions from everyone during the short Q&A. And before Kenny dives in, we do have our first survey question. So you guys will see that pop up here on the screen. And that first question is, what kind of CNC equipment do you want to automate? Please check multiple as they apply to you. Flat table router, pod and rail or point-to-point, programmable saw, horizontal boring machine, or other. So we'll give everyone just a moment to put in their answers. All right, we'll be wrapping up. So if you haven't made your selections, please put them in now. All right, and we'll take a quick look at the results here. Wow, so an overwhelming amount of you guys end up using the flat table router, but it looks like we have a good mix of people using multiple machines in their shop. So now it looks like we're gonna have Kenny take a look at the first subject here.
Here's the benefits for integrating these different types of machines together. First off, we're going to be able to automatically sort parts to go to different types of machines. So for example, if you have a router and a point-to-point and a saw, you could choose to take all of your rectangle parts that don't have any other machining and send those to the saw. And then if they did also have machining, they could be single part programs that go to a point-to-point type of machine. So we could automatically sort those. And then we're also going to simplify the programming of the single parts in the nest. And you'll see that with just a few clicks to go from an assembly all the way through to programming parts and nested components with labels and reports and things like that. And we're going to talk about the labels, because you not only want labels for your nesting on a router, but you're going to want labels for the saw optimization as well. Then we're going to show you a little bit on the new feature in RouterSim called multi-post that lets you take a specific RouterSim job and run it through different types of post processors. That will output for a router, for point-to-point, or for 2 different kinds of routers or 3 kinds of routers that have vastly different programs to them. So we have this feature called multi-posting. So here's an example of an assembly that's done in either AutoCAD 3D Solids or Inventor Solids, SolidWorks, CATIA, Pro-E, Creo, Rhino, different types of 3D modeling packages. And we can take this output from the assembly and send some parts to router, some parts to saw. So you'll see we have a new feature here and a link with Artis, which is one of the best saw optimization packages out there today. And we've made it so it's just one click to get to these Artis files. So we're going to discuss how we have this new partnership and a link with the Artis program, very powerful saw optimization. And of course, RouterSim has its own router optimization and can make programs for single parts on a point-to-point machine as well. So you've got some parts for single parts would be for point-to-point, and then the flat table router, we've got all different types of nesting, including advanced nesting features like common line and stay down and 2-sided nesting, things like that, cart control. These are just some of the features available for how we can simplify their programs. And then you get some idea of what the labels look like. So with RouterSim, you get a full labeling program built in, and you can customize those labels. You could put 2D barcodes, the new 3D QR codes. You can embed label information right into your 3D models. So if you're using Inventor, they're called iProperties, and SolidWorks is just regular part properties. You can put up to 8 label fields built right into the individual parts. And that information passes through to RouterSim. It can also pass through to Artis, where again, you can fully customize labels and you get some really nice labeling for your parts. So we know the labeling is important. RouterSim can also drive a labeling program that, say your machine can automatically print labels and stick them on the parts itself. As the machines get more automated, we can control that too. And we do that for many machines that have automatic label printing and placement. With our multi-posting, it allows you to use many features of the RouterSim database, including the material settings, for example. So you might have one machine that has material that's long in Y and another machine that has material long in X. So when you check these boxes, which machines you want to output them to, and this is just an example of some of the post processors I had on my computer, you could have it use all the settings, including the material settings and the post processor, and all the job settings would be like what the NC code file extension is. So on one machine, it may be .txt, another one might be .mpr or .cnc, and just to give you some example of what job settings would be. And you can have a job that runs through 2, 3, 4, 5, however many machines as you want. And that one job will output the programs for multiple machines with our multi-post. Here's the yield. So, with a saw, you've got the kerf width is only as wide as the saw blade, which is thinner than most router bits, right? So if you've got a lot of rectangular parts, especially if they don't have any other machining, they can be integrated still with your nested based router, and you would cut the rectangles on the saw where you get a better curve, and then cut the machining parts on the router where you could use a stay down or a common line or a two-sided type of nest. So you can have a difference in yields whether you're nesting on a saw or on a router. We give you the best in both worlds with the new saw features that we're going to show you here today. And there's a new questions.
All right, thank you, Kenny, for going over some of the benefits of integrating the various machines. And as you said, we do have our next survey question for everyone. All right, so are you currently using a saw optimization program? Yes, I use Artis. Yes, I use Cutright. Yes, other not listed. No, but want to. And no, I have no interest. So we'll give everyone just a moment or two to put those answers in. All right, everyone, you have just a few more seconds to put those answers in. All right, and we should be finishing up here and take a look at the results. All right, so it looks like we have quite a few people who are actually using different solutions that are listed. And thank you everyone for putting those answers in. And now here's Kenny to go over CIM-TECH's approach, Sasim.
Thanks, Giovanni. Here's a look at our Sasim program. Now, this is the automatic part chooser. So this thing can decide what type of parts to send to the saw or to another saw optimization type program. So with Sasim, it reads our cut lists, and you can tell it to, hey, rectangles with no other features, and send those to Artis. And with that, it makes an Artis file that you double click on, and it immediately begins the saw optimization. So here you could export all parts in this example. If you've got a point-to-point, you want to send them all to Artis so that you cut them and get the maximum yield out of your material. And then one at a time, these parts would go to the point-to-point for processing. So this Sasim is a way to automatically choose which parts go to the saw, and then it'll make a separate list for the router. And so here's a video example where we're going to start with an Inventor Assembly. Now in Inventor, you've got part names and they have a material. And like I said earlier, you could put in iProperties so that you can have label fields built right into the part intelligence. This works exactly the same for SolidWorks, and it works the same for AutoCAD solids. And we can import from dozens of different types of formats. Maybe not dozens, but at least a dozen different formats. With one button click, we're going to make the individual parts with geometry on different layers. So these parts become intelligent geometry. For example, a dado is going to be a rectangle on layer dado. It picks up the depth. It makes a cut list for us that has the name of the parts, the material, and the quantity, and the panel dimensions. And there you see them in those columns. You got the first column is the name from Inventor, the material from Inventor, then the quantity, and then your panel dimensions in X, Y, and Z, and individual X, Y, Z columns there. So we just did the part sizing right there of all those parts. You notice there's 26 parts in that cut list. Now that's all the parts. So there's some other features inside of SolidSim that are worth taking a look at here. This does an expanded view. A lot of people like this expand view, and with this you can build an exploded view, and it's part numbers on both sides. And you're in AutoCAD, so you can make it, even more expanded yourself and print it to a PDF. There's the parts laid flat, and you have full control over what grain orientation, for example, and which side faces up. Full control over all of that. So we really just spent time there to do one button click. Now we're going to use the Sasim and take that cut list that we just made. And in an example here, we could, filter it. We can pick which parts go to artists or which ones go to a router. So here I'm saying rectangles, no other features. Send them to an artist file and pick save. So that's it. You can save these filters. You could put and or. Maybe they have, horizontal and backside features. Okay, so you could build like a intelligent filter list there. So now there's only 12 parts that go to the CNC, and they go to the router. These are the either they're non-rectangles or they are rectangles that do have machining as well. And there at the very bottom is the artist STK file. So with that, we can simply double click on that, and I'll bring up our optimizer program, and we'll get the saw optimization, and really just those few clicks. So we said, okay, here's my 3D assembly. Filter out just these rectangles, send those to artists, and there's the saw optimization for those parts that were outside of, that were inside the Sasim filter list. So artists is a very powerful program. We can do in-depth demos for you if you're interested. It does make output to multiple types of saws, and it has all different features. It has capabilities to run multiple users, and just like RouterSim has post processors, we can output to different types of machines with the artist as well. You can even get it to just prints out the picture for you if your machine is not necessarily programmable. Here's export all parts to artists. Okay, so when we do that, again, it just makes an SDK file with just one click. It's a little bigger than the previous one. That's got all the parts. So that would be good if you're, have a point to point. You want to cut all your parts on the panel saw first. Send them all to the saw, and that's it. Now we could take the remaining parts and send those to RouterSim. So it's a right click and cut with RouterSim Automation Suite. So if you're really paying attention, there's not a lot of clicks. And, I like to focus on that because when you're working with CAD CAM, the work is the clicks. It's not, a lot of people say, well, what's one or two clicks? Well, over the course of the year, it turns into a lot more clicks. So you want to make it, the streamline, the fastest route possible to get that program done. Then you really need to focus on minimizing the number of clicks. What's going on here is now RouterSim is opening up each one of those parts, and it had geometry on different layers. And the layer indicates whether it's a pocket or whether it's a drill hole or inside cut, outside cuts. The feed rates are all set. The spindle speeds, those are what we call machining knowledges, and they're applied to those different layers. And it's all automated. Now, some of these parts even had machining on two sides. And we have a way to do what's called two-sided nesting. We'll show you in a second. I think there was two materials left that needed machining. So here's our first material, and it optimized the yield for these parts. And then there's the second material where it just had one little piece on there. So now we've made, from that 3D assembly, we've made a program to cut the parts on the saw, and we made a program to cut the parts on the router. We've got labels for everything. We've got the NC code files that are ready to run. We've got toolpath simulations. We're going to show reporting and so forth, the material usage report, the labels that we talked about earlier. So this is our cut sim program that simulates the toolpath, and you can pan and zoom this around while it's simulating. And this is a way to see the order of things are happening. Remember I told you we have these machining knowledges. It's like what tool, feed rate, spindle speed, cut direction, type of machining operation. Well, it also has a rank number, what order to do things in. So I did my drilling first, rank number 1, then insides is rank 2. You can make a rank 1.5 that happens in between 1 and 2. Okay, so you're never stuck with any numbers in between there. Here's the RouterSim labels, and you get a full labeling program now with RouterSim, so you can really customize the labels and put whatever information you like on there, whether they're 2D or 3D barcodes. And again, embed that label info right into the 3D model using iProperties in Inventor, iProperties is Inventor, and then regular properties in SolidWorks. And AutoCAD too lets you do it. We have a way we add, update label fields right on an AutoCAD drawing too. So all of the results here are stored in one folder. And here's some other information. They've got the individual drawings with their toolpaths on them. So those are all saved. And that's what we mean by that integration. You've got your CAD and your CAM right inside the one file. There's the backside nesting. It's just a checkbox that's turned on. And now we've got two-sided nesting. So the traditional method for handling parts that have machining on both sides might be, nest them all, and then one at a time, take the part and flip it over and run it on the machine by itself, either the same machine or a different machine. So now we can put the whole sheet on the table upside down and do the backside operations for the parts that are in the nest. Then we trim the edge of the sheet, so when you flip it over, it's a trimmed edge that goes back up against your pop-up pins, which locates it very accurately, and then it does the front side operations. So it's automated two-sided nesting, and the parts come off the table, machined both front and back, right as they come off the table. So this could save you time compared to, like I said, the traditional method, one at a time on the backside parts. So what you see when this does the nest, it does like a mirror image for the backside. So that's the front side. And at the bottom there is the back side, and there was a few tool paths just on that one part, and there's a few tool paths just on this part, and it does a trim edge too. So when the results for this job come out, I'll have two NC code files for each of those sheets, the back side operation and the front side operation. And it's up to you as to what you want to call back and front. You could do it either order. Okay, you could call you decide what layers get cut on the front, what layers get cut on the back. So we call it pre-machining and then the regular machining files. So that was an automated two-sided nest. Now, when you have these RouterSim jobs, there's another new feature here, is in the parts themselves, you can choose which parts go to a saw. So you saw how Sasim did like an automatic filtration. It filtered it based on, condition, whether it's a rectangle or not, whether it has machining on this side or that side. Well, with regular RouterSim now, you can pick output to saw, and then you're choosing which parts go to a saw. So you could do, Control A and select all your parts and pick output to saw, or you could pick them, one at a time and you tell it which parts go to a saw. So that's a new feature in the RouterSim, and here we're showing how SawSim can filter the list, whereas regular RouterSim lets you just pick yourself and create the lists for saw optimization. Now that can also happen during an import. So if you're importing from an Excel spreadsheet, there can be a column in the import that says send to saw. Just a 1 or a 0 in there, and that'll turn that on for RouterSim when you're importing. So that decision could have been made, when you're building your own CSV or Excel file to import. So it's either you do filtering through SawSim, you manually check the box for which parts go to saw, or you could import from Excel or CSV and have it parts marked for saw there. All right.
All right, well, thank you, Kenny, for showing us CIM-TECH's approach to optimizing saws and routers using SawSim and RouterSim. In conclusion, we at CIM-TECH understand how important it is, now more than ever, to keep your shop running as efficiently as possible, making the most of your time in programming your machines, running them, and of course, making the most out of the material you have on hand. This ever-evolving challenge often means that we need to use tools that push the boundaries of automating these processes while maintaining the control and flexibility needed to make changes on the fly. Here at CIM-TECH, we found the ability to integrate all of the best of what various types of machines have to offer in this endeavor and automate them is an invaluable tool that gives you more of the most important of all resources, time. We hope you've seen how this pursuit to automate your various machines can make a difference for you and your team, and we hope that you'll call on us to assist you in this journey. So with that said, we'll open up the floor for some Q&A about today's discussion. And it looks like we already have a few of the questions coming in. So Kenny, looks like one of the first ones we got was, does this work from Rhino 3D parts or assemblies?
It does, yes. Rhino is one of the many file formats you can import. When you start up AutoCAD, you type in import and you'll see Rhino 3DM files right there, and they import perfectly as a 3D model that's ready to go. So we can absolutely work with Rhino and many others.
Okay, good. It seems like that was a pretty common concern. We saw a couple of questions formatted similar to that one. Another one that we saw here, can I make SAW programs from RouterSim parametric macros and 2D parts?
Oh, that's a good question. So today we focused on how to do it from a 3D assembly, right? We took a 3D assembly and SolidSim ran through it and made a cut list, and then we filtered the cut list with SawSim. So if you're going to import from, if you're going to use parametric macros, many times you import from an Excel spreadsheet or a CSV, and there's where you could have a column that says send to saw, and will output those parts to a saw. Now, if you don't have it in your import, you could take a regular RouterSim job, whether it's got macros or 2D drawings or 3D drawings combined. You can mix and match. It's one of another very powerful features in RouterSim is all the different types of files you can mix in a job, and you can manually check which parts go to the saw. So whether you check them all or individual parts, yes, you can do it, and it'll output the artist file.
Okay, great, awesome. So it looks like the next one that we have here, does Sasim work with RouterSim 2019?
We just started the partnership with artists recently, and I think you're going to need to upgrade to at least 2020, 2021, or 2022. So we'd love to show you the advancements in the new version 2022, one of the biggest advancements, 30% faster processing. So you're going to need to go up a version. And also 2022 is going to work with Windows 11. Also an important consideration where 2019 is just a little bit older, and you're going to want to upgrade it to get the SawSim capabilities and artist files.
All right, so it looks like the next one that we had here, can it be set up so that machining can be done on a router, then send the full sheet to the saw for cutting in order to get better yield?
Can you say that one more time, Giovanni? Let's hear
Yeah,
that
absolutely.
one again, because that's a little bit tricky.
Sure, I got you. Okay, can it be set up so that machining can be done on a router, then send the full sheet to the saw for cutting in order to get better yield?
Well, if you're going to do it on the router, you're going to use router nesting. So at that point, the router is going to cut the parts free. If you're thinking about doing the routing and then taking that sheet and put it on a saw, I don't think that's going to work. If you're going to do router nesting, you do router nesting, but we could also take those same parts and send them, create an artist file as well, so that you could have two streams, run these parts on the router, but if you ever need to run them on a point-to-point, you'll have the saw optimization file available as well. So you could do both that way. You can make it optimize on the router and optimize on the saw.
Okay, good, awesome. And then here's another one relating to Artist. So how much does Sasim and Artist cost?
Feel free to contact us for a personal proposal, but the Sasim is an additional product from us here at CIM-TECH. It's $1,850, and it does that part filtering for you. And the Artist program has various modules priced anywhere from $3,000 to $9,000, depending on what levels you get. So you can have have it output to 3 or 4 different saws, for example. You'd get those post processors and go with the all the different modules. And we would love to give you a personal demo on the Artist and go into what each of the modules do. But the budget for Artist, like I said, between $3,000 and $9,000.
Okay, and that totally makes sense. I can see how certain configurations will make sense for one shops versus others. Okay, and here's another good one. Does the Artist program have a network version?
Yes, it does. Absolutely. So similar to Router Sim, it's licensed per user, and they have a network version that installs a key on the network, for example, and then it doles out the license to so many simultaneous users.
All right, and it looks like that might be just about it for today. So Kenny, if you have any other information that you'd like to add on before we completely wrap things up here today.
Thank you again all for attending. We'll have this available on our webpage for review. And again, if you have any questions, feel free to contact us directly for a more personal demonstration and how we could save you time, material, and money with your manufacturing needs.
Thanks, Kenny and Giovanni. Very informative presentation. On behalf of Woodworking Network and CIM-TECH, I want to thank you all for joining us. CIM-TECH software solutions can go a long way to solving productivity issues facing our industry. A reminder, this webinar has been recorded and available on demand within 24 hours. And then finally, please take a moment to fill out the exit survey that'll pop up when this webinar ends. So again, thanks, Kenny and Giovanni, and I'll say so long, everybody.
Thank you all.
Thanks, everybody.